these are a couple of old laptop batteries. They come out of a Dell Inspiron 1525. This was the original pack that was in there. It's 4 cells in series, giving 14.8 volts. It ceased to work, so I purchased another laptop battery. This time it's got 6 cells. These two are paralleled, those two are paralleled, those two are paralleled, so it's 3 cells, 11.1 volts. Now, this stopped working after a while too, so what's going on? It could be a laptop fault, may not be. The only reason I still keep a laptop is to play about with and learn about things, and having something go faulty is quite exciting for me with the old laptop. Now, if you look at the cell voltages, and we'll see if we get a camera in, rearrange this a little bit. We're just going to measure the cell voltages now, and across this one we get 3.644. Across the next pair we get 3.647, and across the last pair we get 3.661. Now they're really quite well balanced. It wasn't like that when I first checked it. This one was quite low, down at about 1.6, that was about 2.5, and that was about 2.5. And I suspect that the battery just switched off because of the imbalance between the cells. Now all that is controlled and regulated by a little board that we can't really see the detail on the board here, and it's quite complex, and if your battery is switched off, there's very little chance that you're ever going to get it switched back on again. To charge the batteries up individually, I used a little power supply that I've got that's got a current limit on it, and set the output voltage to be 3.7, and limited the current to about ½ amp, and then I just gradually charged each parallel pair up to get the balance about right for the battery. Right, now this one is proving a bit of a conundrum. I charged all these up about a week ago, and we'll have a look at this one here, and we'll see that that says 3.5, and come out here. Got to be careful because they're not so sure how these are wired into this one. Up here, that should be, it's reading 3.2, and I come across this one. This is reading 3.3. Now I didn't take too much trouble in trying to recharge these batteries, because this battery was completely dead, and for some unknown reason it is now showing 1 volt across it, 1.025, and I am so surprised because a week ago it was dead. I tested it several times during the week, it was dead. I can't work it out. I don't understand why. We'll talk about this later on, but there's no point looking for trouble at present. I'm going to see if we can recharge this cell and get some sensible voltages out of it. We may maybe just game over for this one, but we'll see. Well, just to prove that I've got it set to ½ amp, there you go, I've got it set to about ½ amp. As this battery one we want to see if we can charge up, and I'll go across, make sure. There and there. And as you can see, we are drawing absolutely nothing. Absolutely nothing. This is weird. Let's come over here. Try it there. Yeah, I think. I can't believe that I'm reading 1 volt across there, and is that because I think we can safely say that this battery is switched off. I think it's very unlikely that it's going to ever charge. If it was going to charge, we would have got a reading there. I'll demonstrate that by going on to one of the other batteries. This battery here. You can see we're at 3.39 and we're currently drawing half amp, and given a little while it should start raising. Here it go, 3.4. It's ridiculous. If I can keep it on the battery, 3.41. It's gradually creeping up when it's taking charge. 3.42. .43, so that battery's taking charge. Similarly, these others will, but that one doesn't, and it just seems to be sort of permanently switched off. Yep, it's off. So we need a new battery for there. We could replace all 4 cells and see whether we get a result, but the expense of doing that is just cheap enough to buy a new battery complete and not worth our while. But this is about learning, and I feel tempted that I would love to do this. I'd love to replace these batteries and then see whether it works. However, let's return to this one. It's now time to put this back in its case. The cells are reasonably well charged, balanced across them, and I'd love to see if it works, because I get a horrible feeling that the little control board has decided that the battery is not non-functional and has locked out. I don't know, I've got no equipment to test that, and there's no point looking for trouble until you know trouble's there. So I'm going to test this one now. I've got the old case that it came out of. No, that's not it. I've got the old case that we've broken open, and I do mean broken open. If you extract the batteries from a case like this, you're going to crack a few things as you go along. It's just inevitable. I'm not bothered if it doesn't work, it's all part of the learning process. Just make sure I get that in the right place. Yep, that's in. That's in. Let's put the top back on. And I think it goes that way around. Might sound like it's clicking together, but believe you me, a lot of the bits and pieces are busted. A lot of it's held in by double-sided tape originally. Well, I got to laugh. I think I'm actually trying to put it in the old case. Oh dear. They're very similar. And we've now got to get it out. Oh dear. Ugh. Yeah, crazy, 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 crazy. Oh dear, oh dear. I wonder it wouldn't fit together very well. Is that? That's in, that's in. In. Well, if you ask me, it fitted together just as well as the other one did. No, it's a bit better. It's a bit better. Right, ready to give it a go. Well, I had a sort of a mad half hour with this thing. And basically speaking, the hard drive wasn't seating properly. However, during that mad half hour, this little light came on, and which is indicating that the battery is charging, which is good. We can now fire it up. I have a feeling that it sort of rewrote the battery while it was fixing itself. So, something funny certainly happened, because that light was not shining, the battery charging light was not shining. Now we do have a very dim display on this, and I know the reason behind it, and I need to fix it, and I will fix it one of these days. And I'm hoping that even though I've got a dim light, we'll be able to see the screen. I'm not interested in the kernel, the machine, etc. But it says about the battery, and it's 35.6% charged, and 73.8, or 73% of its capacity. Its condition is 48.8 or 48.8, presumably watt hours. And it says it's 100%. Which means to say the battery is still very good. It should be, because it was a brand new battery that I put in there, and I got very little use out of it before it crashed. We've got 19 minutes left till we get to fully charged. Now, fortunately, I think I've saved that battery. You might not think so, because all the voltages that I measured sort of 3.6 something or the other. You probably think I was joking when I said what the battery voltages were, but somehow or another we've saved the day with that one. Now I'm going to close this down. I'm going to come back to this battery and we're going to have another look at it. Now, ask yourself a simple question. Why was I getting 1 volt on there, and now I'm getting nothing? I'm puzzled. That is really peculiar. Well, I cannot answer that. I still think this has had it. It was an obvious mistake. I was measuring a negative voltage, which indicates that this was a capacitive charge across that battery. My multimeter is very high impedance and has minimal effect on the readings that we were taking. And had I noticed these sort of very slow but sure drop in voltage measurement as it's sort of the voltage decays and leaks away through the multimeter, I would have realised what was going on. This is a very common effect in all forms of measurement you do on anything. When you start measuring things, you realise the equipment you're using influences the outcome of the result. Some more dramatic than others. The impedance of multimeters varies from model to model, and I'll demonstrate that on the bench just using a simple capacitor, and we'll charge it up to say 3 volts and see what happens. This is a 1000 microfarad 35 volt working capacitor, and we've got it connected up properly, and as you can see on the meter we've got 3.12 volts across it, and that's because that is coming from the power supply. Now I'm going to take that off and disconnect it, and we'll look at our meter again, and you will see that we've got 3.118, 17, 16, 15, so that's 3.114, and it's decaying ever so slowly. And that is because the load that we're putting on there is very minor. Now, we'll change the multimeter to a very old, now this is a very old, I don't know whether we can see the meter reading perhaps. I'll move the camera up a little bit. Oh, hopefully we'll see what it jumps to when I plug it in. Well, first I ought to set the ranges. I've got this set on the 3 volt range, and we'll see where it goes to. Now it's just measuring a little bit low, 3 volts, and we'll wait for it to decay away to 2 volts. But you can see it dropping slowly. Now, but it is faster than the previous meter. This is because this meter registers about 20,000 ohms per volt. Well, we've gone past 2 volts, we're about 1.8 or so. I'll stop there, and we'll bring the other meter back. And hopefully we can still see that. And see the meter reading. We'll see what we've got this time. It should be in the order of about 1.7, I suspect. Yeah, 1.72. If we hold it for a similar length of time, you'll notice that it'll hold that voltage for quite a while. A lot longer than the other meter. Now, I hope I proved my point there, showing that to you. As now I'm aware of it, I won't make that mistake again. I love AVO8s, they're sort of indestructible. Almost. And this will be here long after I'm gone. Okay, it's a bit of a museum piece, but it works, it's reliable, and the AVO8 was sort of a go-to multimeters back in the days before companies like Fluke started out. Now, talking of digital meters, I don't know how well calibrated my digital meters are, but I would suspect that I could get more accuracy with the digital meter, or repeatable accuracy with the readings. I mean, bear in mind you've got to sort of, there's a little mirror in these things here, so you sort of have to look at it from above to avoid a parallax error, and using the reflection to line up the needle and then interpret where it is on the scale, and that in itself is prone to error, let alone the sort of errors in the movement of the multimeter. So you can expect, let's be generous and say you'd be lucky to get better than 5% accuracy with a meter like this, whereas even with a little digital multimeter, provided it hasn't got any sort of what you call it's been set up properly in the first place, you'll get more repeatable results using one of these, just from the point of view of not making any errors with the reading that you take visually here. Now, it doesn't mean to say this is more accurate, because all meters have to be calibrated.